Hey, welcome back everybody to another Coding Corner here at Social Bakers. Once again, I'm Tim, and here today with us we have Milan Lepík, and he's been with the company quite a long time, about 7 years out of our 10 total. And if you would, just introduce yourself real quick, kind of tell us your story with Social Bakers.
Hello. I'm Milan, as Tim said already. I work for Socialbakers since 2012, where I started as a programmer, as a guy who's getting data from social networks. So it was mostly about data processing. Then I moved through different management and technical roles, and now I work as director of data platform. So I'm overseeing all the data processing technologies and databases.
Cool, yeah. So you and I actually work really closely together. So since January, I moved out of a more front-end role and into a back-end role into the parsing team. And we've been trying to build a new system that is currently comprised of kind of a bunch of older legacy systems, some PHP and CoffeeScript and JavaScript and TypeScript, etc. But we're really focusing on reliability. And the reason we have you here today is to kind of just talk about reliability and the concept of sort of condition monitoring and just operating a system. We take in, just to give you a bit of background, our department is the parsing department, which basically takes in all of the data from external sources, the social networks. So in order to serve our customers correctly, we have to really reliably bring in all this data. And you and I have been working really closely on that. So just, in some summary, give us your thoughts on kind of what makes things reliable and what our focus has been on.
So I have to tell that I like backend work and backend development really a lot. And there is one thing that's missing that's the main difference between backend and frontend. The thing is that we don't have any visualization until we do some. And usually when backend developers do some front-end visualization, it's horrible. We don't have time, we don't care. It's not very user-friendly. But it's really important in order to monitor the system, right? Because the system itself, as I see it, is composed from three variables. One is the software, second is the hardware, and third one is the data. We can have perfect software with a lot of tests covered. We have, of course, we have unit tests, we have integration tests, we have also some manual testing. We have hardware, which is monitored by DevOps. We have charts, all sort of indicators to find out whether there is no hardware failures. And then data. We should monitor data in long term, because we design a system, we parse and download data, but a year later, we find out that something's wrong with the data, and we should find out much sooner than customer finds out. So we should build a system from which we are able to monitor whether the data are okay today or not. And as I told you, we don't want to create a front-end system. So basically what we do is creating dashboards in Grafana, or actually we're creating dashboards in Grafana and Kibana as well. And nowadays Kibana is the main source of graphical user interface for monitoring data. And this monitoring helps us to understand what's the typical or the happy path of the data processing. It helps us understand how many times we have to deal with exceptions in the system. So over time, we see that the exceptions are stable between some percentage that we choose for this use case. Mm-hmm. Or if it's crossed the percentage, then we can take an action.
Yeah, so just to recap that a little bit. So yeah, I think, you mentioned the software problems. Yeah, me coming from the front-end developer role more to this sort of living back-end, because even when you're doing back-end for more of web server type stuff, it's very kind of short-lived transactional stuff. So you just have a request some HTTP request, it does something and sends something back, which is like very incidental. But we have in the parsing department, we have a lot of these like really. We have infinite loops, effectively. We have this while true loops that are doing polling against databases, a lot of job scheduling. They constantly run. And I think one of the first things I noticed was, like you said, there's the software issues. You sit in and you run your tests and everything passes and you're like, oh, everything looks great. And then you get into, deploy it up into the servers or whatever production. And one of two things typically happens. Either it just crashes, and at first this was a huge mystery to me. And the second thing is it just it runs really, really slow. So I think I would like you to describe kind of two things here. One is that there's making the code work, and then there's this idea of like specification. The realm of specification is basically not only does your code have to work. So let's say normally we have something like a user story that says we need to, like ours in a parsing department, we call Facebook's API and we get some information and we transform it into some form and then we store it somewhere. That's easy to write code for. But then there's this realm of you need to do that 10 million times a day. So we have this two sides of specification, I think. One is we need to meet customer demands. So we need to do this, this customer's data needs to be this fresh. And in order for our product to basically meet the agreement that we have with the customer, we have to do it, that 10 million times a day because we have this many accounts and this many customers, et cetera. The other side of that is based on doing it 10 million times a day. You have the specification for your infrastructure. Mm-hmm. So you're like, you have this responsibility. Maybe you don't own it because we have DevOps, but you have to communicate with DevOps because, they're the people that, procure and maintain these systems. So if we're going to do something 10 million times a day, we have to have the database capable of doing that. So yeah, it's been really, really interesting to try to have to deal with this. I think the other side, like I mentioned before, is also running things in your local system can actually pass or succeed because they're so slow. And when you get up to the production systems, you have a lot lower latencies when you're inside the cloud. And then all of a sudden you're like overflowing the heap with like promises because things are just going way, way, way too fast. So one of the things you mentioned earlier was about the business goal. Mm-hmm. And I find that if you start logging a bunch of stuff, you can get really overwhelmed by logs. So describe kind of how you overcome that. Like how do you structure your dashboard or you structure the information that you're presenting to you or your team so that it doesn't become like overwhelming or useless?
Yeah. So let's say we collect this many information and we have a problem that we don't know which is like more important than the other. That's when the mess starts. It's not because of the number of logs, it's because we like hierarchy. Mm-hmm. So if we integrate hierarchy into logging system, so we set up like mission critical goals, like severities there. We can also split logs by like which are the like really system critical ones and which are like the specific system ones. We can make it like much better, and even we are collecting tons of logs, we are able to distinguish what kind of data are important right now in the system and what's like more like debugging information. Mm-hmm. So hierarchy is the key, and we should decide not only hierarchy when it's about logs. We should design it into dashboards as well. So we should use like one main dashboard, which tells you just like overall information whether the system is performing good or not, mm-hmm. or like we can have really a lot of numbers on one dashboard. If let's say we change the color of the number there on the dashboard. So probably I don't know what's the good rate for like saving rate of like tweets or Facebook posts.
Yeah.
But I designed a system that we set some ranges when it's good. It's like 100,000 per 10 minutes is okay. It should be green. If it's like 10,000, we probably have a problem. It's orange, and if we have like less than 100 or 0, it's red. And from this dashboard, if I have a lot of information, it's not just a table full of numbers. It's a table full of numbers and colors, so I can see what's red, what's orange, and how many numbers are green, orange, or red, and understand what's the current situation.
Yeah, that's. I think you hit on two really big things there. I think one is just using really like simple visual indicators like red, yellow, and green. Because I've seen some dashboards in the past before. They're just more like logs, or you get your Slack channels are getting messages and things, and it when something gives you too much information, it basically gives you no information. The second thing I like there is this hierarchy. I think a good example from our perspective, which we've been trying to build, and I really want to implement this, is you've got your main business goal, right, which is to satisfy like a customer agreement. So if we've got a customer and they're monitoring like 5 social media profiles, and we've got some agreements that those social media profiles should be downloaded, once per hour, we can actually say that is happening. So that's our first measurement. So if that is happening, and then everything's green, which is great. But if it's not happening, let's say it's red, we actually derive that measurement from something else. So we start with like the most derived thing, which is, am I downloading the stuff at the right frequency? But then the next thing is, let's say, the actual jobs that do the downloading. And so we, once again, just like you said, we start at this super simple dashboard. If everything's good, go back to work. If it's not good, you go to this next dashboard that says, hey, how are my jobs executing? And you'll see more details. And then if you need to go somewhere else, maybe you actually go to the error logs themselves and you actually start digging through those. So this is the structure that we're trying to build here. We've got it I'd say about 70, 65% done. But it's been super helpful already in troubleshooting a lot of things. Are there any like kind of final points that you'd like to?
Yeah, there is one point when you're building this specific dashboard for the use case. It's good to have the same approach as when you are try catching the errors. So build the logs as closer as possible to the code itself, which is influencing the performance of the code. So if you have the specific dashboard and it's just saying what's the saving rate right now, it's probably not the right number. If you have like 3 databases, you probably should like log each database separately, have just 3 lines on one chart and understand which database gets slower. When you're building the specific dashboard, you can go as close as possible to the cause of the issue. So every like critical slow operation should be like logged there. Then also one more thing that can really help with understanding dashboards is if you have it near your eyesight. So you probably create a dashboard and you don't have time to look into it whole day. So you are probably programming. You don't want to be interrupted in your work. It's highly specific. It's difficult. So you want to have the vision of everything is fine because I see it there on the right side. It's all green, so I can work fine. And if it's not, I should probably understand what's the problem, whether I was the one who caused the problem, so I should fix it. Because, of course, we have alerting. Alerting helps a lot, but in case you have a big problem that's not caused by you directly, but your other team member or some external service, you as a developer on duty probably receive not only one alert message, you will receive 100 messages, and understanding what went wrong is then like quite slow. So if you have this dashboard, you can go back in time and see what was read first and what time it happened, and you don't have to dig into alert messages and find out what's wrong. You have dashboards and see, okay, this part of the system is wrong. I should probably inform support that something's going on. Right now, we are doing everything what we can in order to recover the state and let's say send messages to client and then work on the bug itself.
Yeah. I think just in summary, you know, we're really focusing on reliability here. We've been really working, and we've noticed that, you know, just error management and logging of errors hasn't, you know, it's been really small part actually of understanding whether we're really, you know, bringing a good product to the customers. So we decided to use Elasticsearch with Kibana. It's open source. It really visualizes things really well, and we're just focusing on right now about every time we sort of have some sort of operational issue, we do a failure analysis, and we basically say, hey, how do we make sure that we know that something's wrong before the customer knows? So that's really what we're trying to pursue. So hey, man, thank you for coming by. Thank you for talking, and I hope you guys found this video useful. Thank you.
Thank you.